Hello, my name is Jamie Guo, and this is my Physics 2212 Lab 1 report charge tapes. So the purpose of this lab was to approximate the x-axis charge on a piece of charge tape. Some fundamentals to keep in mind is that Coulomb's law states that force is equal to k times q1 times q2 divided by r squared, and that k is equal to 1 divided by 4 pi epsilon naught, which is the Coulomb's constant. Force of gravity can be found through mass times acceleration due to gravity, which is 9.8 meters per second squared. The E field of a point charge is equal to k times q divided by r squared times r hat. Like charges repel, opposites attract, and that the charge of an electron is 1.6 times 10 to the negative 19 coulombs. So for the experiment, I began by preparing two pieces of charge tapes. I then hung one tape between the table and put the other tape right below it. I then found the distance between the two tapes when the top tape began to levitate. So some assumptions made for this lab was that air resistance could be neglected. Both charge tapes are point charges, and both charge tapes have the same charge. Some initial conditions found was that the length of the tape was measured to be 0.17 meters. The mass of each tape was 0.0002 kilograms, and the distance between the tapes when tape B began to float was 0.025 meters. In this case, our system is tape B, and the surroundings is tape A and the Earth. So some results found throughout the experiment was that the tapes are positively charged. The charge on each tape is 1.16726 10 to the negative 8 coulombs, and the gravitational force and the electrical force was 1.962 10 to the negative 3 newtons. So for part one of the computational model, the goal was to calculate the gravitational and the electric force and the charge on the tape. This was done by plugging in known values that was measured and calculated, and then finding the force of gravity, which is found by mass times gravity, acceleration due to gravity, and setting that equal to the electric force, as theoretically the two should cancel out since the tape is floating. And the bottom part of the code is used to find the charge on each tape, and results can be shown on the right. So for part two of the computational model, we're assuming the tape to be a line charge instead of a point charge this time for a more accurate representation. So we started by plugging in the mass and the charge found from part one. The bottom left here, this is the code written to calculate the electric field of each particle. And on the right, this code was manipulated to calculate the electric field of the top tapes due to the bottom tapes charges. On the left, this code was written to have arrows represent the forces on the right. And on the right, the green arrows represent the electric field felt by the top tape due to the second tape or the bottom tape. The white arrow is the net electric field force, and the yellow tape is the gravitational force. And in this case, our electric force was a little smaller than the gravitational force, and this could have been due to errors throughout the experiment. So some potential errors in the experiment. There could have been inaccurate measurements of the length and mass of the tape. There also could have been an inaccurate measurement of the distance between the two tapes, as there's human error involved in this kind of experiment, and that there could have been a loss of charge when transferring tapes between hands. So, what if electrons were positively charged and protons were negative? What would change about the observations you made with your tapes and other charged objects? So the observations would be the same as like charges repel each other. The tape would just have a negative charge instead and have an excess electron instead of and too much. So why are point and line charge models results different? Which value is more likely to be closer than the real value and why? Point charges is an oversimplified version of the real-life electric field interaction. The line charge accounts for the distribution of charges across the tape, so it is closer to the real value. Thank you.